The universe is this big, this old, this full. So why is it this silent? This question is one of the deepest questions ever asked in history. A scientist once asked this question during lunch. Everyone at the table laughed, and it seemed as if the subject had ended. But the question did not end. That day, the Nobel Prize-winning physicist Enrico Fermi, sitting at that table, had unknowingly touched one of the greatest mysteries in human history. And since that day, no alien signal has arrived, and no real explanation for the silence has been found. We are here, inside the Milky Way galaxy, on a small planet among billions of stars, a species that is intelligent, curious, makes tools, writes poetry, and sends rockets into space. And we still do not know whether we are alone in this universe. Now let me tell you this. Truly grasping the size of the universe is almost impossible, but I will try to explain it not with cold numbers, but by making you feel it. Inside the Milky Way galaxy, there are roughly 200 to 400 billion stars. To understand what that means, imagine counting every grain of sand on every beach on Earth. That number comes close to the number of stars in the Milky Way. But the universe is not only the Milky Way. Inside the observable universe, there are around 2 trillion galaxies similar to the Milky Way. 2 trillion. That means there are 2 trillion galaxies, each one filled with stars like grains of sand on beaches. And in most of these galaxies, around most of these stars, there are planets. In the last 30 years, humanity has discovered thousands of exoplanets. There are Earth-like planets orbiting stars similar to the Sun, in places where water could exist, in regions with suitable temperatures, in systems that may have remained stable for billions of years. So the stage is this large, this varied, this wide. And you are still asking the same question: why are we alone? Here, we need to talk a little about statistics. When calculated mathematically, considering that the universe is this large and this old, the chance that there is no other intelligent life begins to look extremely low. There are star systems that formed billions of years before us. The planets in those systems warmed under suitable conditions for billions of years. If life could form on Earth, and if evolution could produce an intelligent species here, should that not have happened somewhere else too? It seems logical. It seems almost inevitable. But the universe is silent. The first person to place this silence into a serious scientific framework, about 10 years after Fermi's lunch conversation, was another scientist. The astrophysicist Frank Drake wrote an equation in 1961. This equation tried to estimate the number of civilizations in our universe that could communicate with us right now. It asked, how many stars are born each year? How many of those stars have planets? How many of those planets are suitable for life? How many of those planets actually develop life? How many develop intelligent life? How many develop the technology to send signals into space? And how long those civilizations survive? Whatever the result was, the real value of the equation was not the number. It was the way of thinking. It was turning Fermi's question into an engineering problem. It was trying to calculate how many there should be. But the more that calculation was made, the heavier the silence became. Some scientists used this equation and estimated that there could be millions of civilizations in our galaxy. Some limited the number to thousands. But all of these estimates had one common result. It should not be zero. Not 1 or 2, but many civilizations should exist. And yet, we still have not received a signal. For decades, giant telescopes scanned the sky. Radio waves were listened to. Strange flickers in the light of stars were examined. Unusual signals were investigated. Not a single definite answer came. What makes the situation even more surprising is this. If there are millions of civilizations in the universe, and if even one of them had expanded through its galaxy by traveling, colonizing, or spreading signals, then we should see the traces of that expansion today, because the universe is this old. A civilization expanding for billions of years could theoretically have covered its entire galaxy by now. But there is no trace, no signal, no structure, no footprint. This situation is known as the Fermi Paradox. The paradox is this. Statistics and probability say the universe should be full of other intelligent life, but observations say the universe is silent. How can these two things be true at the same time? Maybe the question itself is being asked in the wrong way. Maybe alien civilizations exist, but they are not sending signals to us. Maybe they do not use radio waves like we do, and we are listening to the wrong frequency. Maybe they are sending signals, but we have only just begun listening, and they have not reached us yet. Or maybe the universe is so large that as signals travel across billions of years of distance, they become so weak that they can no longer be detected. Or maybe there is a darker answer. Maybe civilizations really do form, grow, develop, and at some point, they always disappear. And maybe this disappearance is such a universal fate that no civilization can survive long enough to break the silence of the universe. This possibility may be the most frightening interpretation of the Fermi Paradox, and this interpretation is called the Great Filter. But for now, let us put this idea aside. First, we need to understand this. How likely is life in this universe? What does life need in order to form? Scientists have studied this question for decades, and the answer is becoming more and more hopeful. First, life needs complex chemistry. Carbon, nitrogen, oxygen, hydrogen. These are the basic elements. And these elements are found in abundance throughout the universe. Because the things that can produce them, stars, exist in every corner of the universe. Life needs water, liquid water. And water is also extremely common across the universe, from icy comets to beneath the surface of Mars, from under the frozen crust of Jupiter's moon Europa to the rings of Saturn. We see traces of water everywhere. Not only on Earth, even in this solar system, water is hidden in many places. Life needs time, long, stable, uninterrupted time. On Earth, the first single-celled organisms appeared about 4 billion years ago. Multicellular life appeared only around 600 million years ago. The human brain appeared in the final second of this timeline, with a history of only about 100,000 years. For an evolution that takes this long, the star system has to be stable. The star must not flare too violently or fade too much. The planet must be at the right distance. Large planets around it must help protect it from asteroid bombardment. A large moon like ours must stabilize its axis. All of these exist on Earth. But what are the chances that all of them exist together on another planet? Scientists tried to calculate this, and the answer was surprising. Life may still be able to form, even if all of these conditions are not present together, because life is much more flexible than we expected. On Earth, living things exist at the bottom of the oceans, around boiling hydrothermal vents, where no sunlight reaches. There are bacteria living inside radioactive waste. There is life in desert heat, in Antarctic ice, in lakes saturated with acid. Life can adapt to almost every condition. This flexibility suggests that life may be much more common in the universe. Maybe beneath the icy shell of Jupiter's moon Europa, in the dark depths of an ocean, single-celled organisms are alive. Maybe the water geysers erupting from Saturn's moon Enceladus carry organic molecules. Maybe deep beneath the layers of Mars, where frozen water melts, something is moving. But this is the biggest issue. There is a massive gap between single-celled life and intelligent life that produces technology and sends signals. And crossing that gap may be a much rarer process than the existence of single-celled life itself. On Earth, life remained at the single-celled level for 4 billion years. It seemed to be going nowhere. Then multicellular life appeared. Then skeletons developed. Then brains. Then language. Then writing. Then technology. Each of these steps was an independent revolution, and each one required very specific conditions. Maybe there are single-celled organisms in every corner of the universe, but intelligent civilizations, civilizations that communicate, civilizations that go into space, may be extremely rare, maybe even singular. Maybe it is only us. This thought takes the mind to a strange place. On one side, trillions of stars, billions of galaxies, space that seems almost infinite. On the other side, us. In this entire stage, maybe the only beings that speak, understand, and question are us. And this loneliness is both frightening and fascinating. Because if you are truly alone, then you are the only thing that can understand this universe. The only being looking at the stars, understanding them, naming them, and sending rockets toward them, lives on this small planet. But the silence should not discourage us, because we still know very little. It has been less than 100 years since we discovered radio waves. It has only been a few decades since we opened antennas toward space. The Milky Way galaxy is 10 billion years old. On this scale, we are very new. Maybe we are only just learning how to listen, and maybe the universe is listening to us. In the next section, we will examine the possible explanations for this silence one by one. Why are there so many answers, but none of them enough? Does the great filter really exist? And if it does, is it behind us or waiting ahead of us? And what would happen if someone reached us? We will follow these questions. In 1977, a radio telescope at Ohio State University received an unusual signal from the sky. This signal lasted exactly 72 seconds. It was so powerful, so regular, and so unexpected that the scientist watching the telescope output looked at it and wrote a single word beside it. Wow. That signal never came again. Never. For decades, telescopes were turned back toward the same region of the sky, but they never captured that signal again. What it was is still unknown. Some argued that it came from a natural source. Some claimed it was a misreading, but a significant number of people thought this. What if it was real? In a universe this silent, that 72-second signal lodged itself in the human mind like a splinter, and it is still there. For decades, people have thought, written, and speculated about the answers to this silence. But none of these answers are completely satisfying, because every answer creates a new question. Now let us look at these possible explanations one by one. The first thought is this. Maybe we really are alone. The universe is this large and this old, but accepting that we are the only beings before we can even understand it feels very difficult. But when we look at it honestly, this possibility is not zero. In fact, according to some scientists, it is quite realistic. How often do the conditions needed for life to begin come together? We do not know. We do not even fully know how life began on Earth. In laboratories, amino acids can be produced. Organic molecules can be synthesized. But how the first cell formed still remains largely a mystery. And the rarer that mysterious starting point is, the rarer it must be elsewhere too. Maybe life forms around only 1 out of every billion stars in the galaxy. And even that 1 in a billion rate would still mean that millions of living worlds should exist. But what if the rate is not 1 in a billion, but 1 in every trillion stars? Then maybe there are only a few in the Milky Way. Maybe there are none. Maybe we are the one. The second thought stands in a much more interesting place. Maybe they are out there, but we are looking for the wrong thing. We are listening for radio waves. The reason is very simple. We can send and receive radio waves. But radio communication is only one of the methods humanity invented. And maybe it is a very primitive method in the universe. A civilization that formed and developed millions of years ago may have left radio waves behind long ago. Just as we do not use Morse code today, they may have moved far beyond radio signals. Maybe they use pulses of light. Maybe they communicate at the quantum level. Maybe they use physical phenomena whose names we do not even know yet. And there we are, with our giant ear, locked onto the radio channel of the universe, missing everything outside that frequency. Let us make this comparison more concrete. You are lost in a forest, and there are wild animals around you. You want to hear them, but you have tuned your ear to only one specific wavelength, and on that wavelength, there is no sound. That does not mean there is nothing in the forest. It means this: the thing you are looking for may be communicating not with sound, but with something else. The third possibility is both frightening and extremely logical. Maybe they are out there, but they are deliberately silent. In other words, they consciously choose not to send signals. Why would they do this? Maybe the universe is dangerous. Maybe a civilization that discovers the existence of other civilizations finds it safer to hide rather than reach out to them. This is called the cosmic dark forest theory. The forest is large, and you do not know what is behind every tree. So the smartest strategy is to stay silent. Think about it for a moment. When we think about our relationship with our own species on Earth, we see what can happen when a more powerful civilization meets another one. In history, when a less developed society made first contact with a more advanced society, the result was usually destructive for the weaker one. A civilization that knows this may think very carefully before saying hello to the universe. And for that reason, instead of sending radio signals, they may choose to watch and wait. But this thought brings the opposite concern with it. What are we doing? For years, we have been spreading radio signals. Our television broadcasts, our military radars, our high-powered communication signals have been spreading into space for decades. If someone truly dangerous is listening, and if silence is a security strategy, then we have done the opposite. We have become one of the loudest civilizations in the universe. Some scientists who take this idea seriously have warned about whether we should send messages into space, because those signals have been sent and they can no longer be taken back. Tens of light years away, they continue to expand and spread. The fourth possibility is both the simplest and the deepest: distance. The universe is so enormous that it is not enough for two civilizations to exist at the same time. They must also be close enough to receive each other's signals, and this condition is not always met. Think about it. Let us say there are 500 intelligent civilizations in the Milky Way, and all of them emerged at different times. The first civilization existed 2 billion years ago and disappeared after 1 billion years. The second began 1.5 billion years ago. The third began 1 billion years ago. And we began only a few thousand years ago. On this timeline, most civilizations never catch each other. It is like runners entering the same racetrack at different times. They all exist, but they are never in the same place. This idea is deeply sad. Maybe a civilization in our galaxy was capable of sending us a signal, and it sent that signal. But by the time that signal traveled through space for millions of years and reached us, that civilization had already disappeared. Or the opposite. Maybe we sent a signal, but the civilization that could receive it does not exist yet. The signal drifts through space, waiting, and we are waiting for a civilization that has not yet been born. And now we come to the Great Filter. This theory is both one of the smartest and one of the most disturbing ideas. The Great Filter says this: there is an obstacle on the road between life and a space-reaching civilization. An obstacle so massive, so universal, so difficult to pass, that almost every civilization gets stuck there. Passing through this filter is extremely rare, and that is why the universe is silent. So where is this filter? The answer to this question is critically important for the future of humanity. If the Great Filter is behind us, meaning we have already passed this obstacle and left it behind, then there is hope. Maybe the transition from single-celled life to multicellular life was the filter. Maybe the development of conscious intelligence was the filter. Maybe developing language, society, and technology together was the filter. All of these are extremely difficult steps, and we achieved them. In this interpretation, we are one of the rare miracles of the galaxy, and there is an open road ahead of us. But if the Great Filter is ahead of us, meaning we have not passed this obstacle yet, and it will meet us in the future, then the picture becomes much darker. Every civilization grows like us, develops like us, produces technology like us, and then, at some point, disappears. Nuclear war, climate catastrophe, artificial intelligence going out of control, a giant asteroid, a trap discovered billions of years ago, but still not understood by us. And this trap is so universal that almost no civilization survives it. When you think about this second interpretation, finding traces of other intelligent life in the universe would actually be bad news. Let me explain. Imagine we found fossils of single-celled organisms on Mars or on Europa, a magnificent discovery. But in reality, this would tell us that the Great Filter is not behind us, because it would mean that the beginning of life was not the filter. Many places past that stage, then the filter is ahead, and that means there is an obstacle waiting for us. Robin Hanson wrote about this idea in detail in 1998, and since then, it has become one of humanity's great existential questions. We study the universe, we search for planets, We search for signs of life, but maybe whether what we find is good or bad depends on how complex the thing we see is. If we found simple organic molecules, that would be good, because it would mean the filter is somewhere that has not yet been crossed. If we found fossilized single-celled life, that would be very uncertain. If we found signs of multicellular life, that would be worrying. If we found the ruins of a civilization, that would be terrible, because it would show that there is a filter that every civilization passes through and dies in, and we have not passed that filter yet. This logic shakes a person from a very deep place. While trying to explore the universe, we may actually be searching for clues about our own end. So have we found anything truly hopeful so far? Actually, there are a few interesting observations. In 1996, when NASA scientists examined a meteorite that had fallen to Earth from Mars, they found organic molecules and tiny shapes inside it. The question was asked, could these be microfossils? The debate still continues, but no definite conclusion has been reached. In 2020, phosphine gas was detected in the atmosphere of Venus. Phosphine cannot be produced under Venus conditions by known processes. Could there be a biological source? A major debate began. Later analyses showed that some measurements were flawed, but the idea was not completely rejected. A star called Tabby's star shows extremely strange and irregular dimming. No known natural mechanism fully explains why sun-like stars behave this way. Some connected this to a giant structure built around the star, a Dyson sphere, a megastructure that collects the energy of a star. This idea attracted great attention, but in the end, dust clouds became the more likely explanation. Still, this star has not been completely solved. Every interesting observation created excitement for a while, and then was softened by more ordinary explanations. It feels as if the universe keeps misleading us. Or maybe we want so desperately to find something that we see aliens in every anomaly. In the next section, we will talk about this. If one day we truly encountered another civilization, what would happen? How could this encounter take place? And most importantly, after knowing all this silence and loneliness, what does this life tell us? Big questions sometimes make the smallest things more meaningful. In 1990, as the Voyager 1 spacecraft approached the edge of the solar system, Carl Sagan made a special request to NASA. "Turn the camera around," he said. "Look back at Earth." The engineers found this technically unnecessary. If the camera was pointed at an angle too close to the sun, it could be damaged. But Sagan insisted. The camera was turned, and in that photograph, inside the rays of sunlight, a pale blue dot appeared, smaller than a speck of dust. That was Earth, the place where all of humanity lived, fought, loved, cried, and hoped. A single pixel inside the universe. Sagan looked at this photograph and then wrote those famous words. On that pale blue dot, think of everyone you know, everyone you love, everyone you have ever heard of, every human who has ever existed, every hero who ever lived, every dictator, every saint, every sinner, the full weight of history, love, pain, indifference, all of it was there, on that tiny dot. These words are not simple romanticism. They are the expression of a deep physical reality. We are so rare inside the observable universe that somehow we have brought ourselves into existence, and that rarity carries a meaning all by itself. Now I want to ask this question. What would happen If we really encountered another civilization, people who think seriously about this question predict that the answer would most likely begin with the reception of a radio signal. A researcher working a night shift looks at the screen and sees a signal different from every known natural source, a signal that repeats and carries a mathematical structure. At first, they do not believe it. They check again. They wake up their team. The team does not believe it either. They try to confirm the same signal with different telescopes, and it is confirmed. Then what happens? According to historical protocols, this discovery would not be shared with the public immediately. Independent verification would be done. The scientific community would be informed, and eventually, an announcement would be made. Another intelligent source has been found, but after that point, nothing is predictable. Because this event would be the greatest paradigm break in human history. Religions, philosophies, cultures, national identities, laws, economies, all of them would be shaken by this discovery at the same time. If we are not the only witness of the universe, what does that mean? How would the idea of God be affected? How would we define our place in the universe? And the truly frightening part is this: communication. If that signal reached us, it would have come from thousands of light years away. If we sent a reply, our answer would travel for thousands of years, and when it reached the beings there, we would already be gone. Not a few generations, tens of thousands of generations. This picture makes a real dialogue impossible. There are only monologues. We shout, they shout, and neither of us can ever truly receive the other's answer. The universe introduces us, but it does not seat us at the same table. But what if that signal was not only a signal, but a visit? Thinking about this scenario is much more complicated, because without exceeding the speed of light, interstellar travel is not possible with today's physics. A civilization capable of crossing that distance would have to be almost infinitely ahead of us technologically, and that difference in power would create a situation unlike any encounter in history. For this reason, some thinkers argue that even if an alien visit existed, it would remain silent. Maybe they are watching the universe, but they prefer not to interfere. Maybe they see us as a kind of natural process and do not want to disturb that process, just as humans sometimes choose to observe isolated communities in dense forests without touching them. Maybe we are not completely abandoned. Maybe we are under an observation we are not aware of. This idea is both comforting and unsettling. Comforting because it may mean we are not alone. Unsettling because living without knowing that we are being watched leaves a strange feeling behind. But now let us step back a little. Out of all these big questions, let us turn toward a smaller but more urgent question. What use is it to learn these things? Why are we trying to understand this cosmic loneliness? The answer is directly connected to where humanity sees itself. The Fermi Paradox is not only a scientific question, it also contains a warning about the continuity of our own existence. If thousands of civilizations formed in the galaxy, and all of them disappeared, we may be one of them too. And what were the common factors in their disappearance? Understanding this could perhaps delay our own end. Think about what we know, about the great civilizations that existed and disappeared throughout history. All of them seemed enormous in their own time. All of them believed they were permanent, and all of them turned out to be temporary. And their histories, when compared with ours, are not even longer than human history itself. On a cosmic timeline, They all burned and went out in an instant. This pattern, this ease of disappearance, may be the essence of the great filter. Intelligence develops, technology grows, power increases. But at some point, that power becomes large enough to destroy the civilization itself. Nuclear weapons made this possible. Climate change may make this possible. Biotechnology may make this possible. Artificial intelligence may make this possible. Every technological leap brings liberation, and at the same time, a new risk of destruction. If we assume that every civilization, when it reaches a certain level of maturity, gains the ability to destroy itself, and then uses that ability, then our traces do not remain in the universe. Ruins collapse over billions of years, are erased, and mix into the light of other stars. And everyone who encounters this idea comes to the same place. We are right in the middle of this fragility. As a civilization, we are rising toward a peak, but we do not know what lies beyond that peak. Now let us look from a completely different perspective. When you accept and internalize the silence of the universe, how does your view of life change? Some philosophers and scientists who ask this question seriously come to this conclusion. Silence actually increases our responsibility. If we are the only beings in the universe who understand life, feel it, wonder about it, and write poetry, then this capacity for understanding is extremely valuable. And protecting it, developing it, and carrying it forward falls on us. Carl Sagan once said something like this: "The universe is trying to understand itself, and we are part of that process." Atoms born inside stars came together billions of years later and began trying to understand the universe. From this point of view, curiosity is not only an intellectual activity, it is the universe's attempt to understand itself. And this attempt is fragile. Because the being that makes it, meaning us, can continue that attempt only as long as we live carefully. Every scientific discovery, every act of understanding, every new generation's curiosity is the continuation of this effort. Why is the universe silent? Maybe because continuing this effort is truly very difficult. Maybe because every civilization silences itself at some point. Maybe because we are very rare, and we do not realize how rare we are. But maybe, and this is my favorite possibility, maybe it is still very early. The universe is 13.5 billion years old. Human technology is only a few thousand years old. Radio signals are only about 100 years old. On this scale, we have only just been born. The signals we have sent have traveled only about 100 light years away. Not even 1% of the diameter of the Milky Way. Maybe there are many civilizations out there, and all of them are patiently waiting to receive each other's signals. Maybe intelligent beings in different corners of the galaxy are looking up at the sky. Maybe we are among them, but we have not yet become loud enough to reach one another. And thousands of years from now, maybe one day, two signals will find each other. A young researcher sitting at a radio telescope will hear something meaningful one night, and that moment will be one of the greatest moments in human history. What will we do until then? Maybe this. We will keep asking these questions. We will keep this curiosity alive. We will continue trying to understand the universe, and continue being the ones who tell its story. Because questions sometimes live much longer than answers. And this question, the question of where they are, proves something as long as it stays with us. We are still curious. and a civilization that is still curious has not disappeared yet. When you open the window before sleeping at night and look at the sky, look once more at the stars inside that darkness. They are silent, but you are not. You are the one who understands them, names them, watches them, and wonders about them. And this, inside this enormous and indifferent universe, is something incredibly small, but incredibly valuable. The universe looks empty, but you are looking, and looking is already an answer.